For the next person, we switch again to English, and I'm very happy to welcome Rachad Nassar on stage. He is Global Account Director, Smart Transportation Business Unit from Huawei Technologies. Welcome on stage.
Hi, everyone. Good afternoon. I'm so delighted to be here among you to present you part of Huawei ITS solution. But first, let's start by addressing the challenges that the road sector is facing and the major cities are facing. First is the traffic death and traffic injuries. According to the statistics that we can see here, 1.19 million annual traffic death worldwide. 20 to 50 million annual traffic injuries worldwide. And you can see that's impacting all regions. For sure, less developed countries and less developed regions are more impacted than developed countries, but still it's a major challenge. The second one is the congestion. 55% of the global cities around the world are facing traffic congestion, especially at peak hours. And you can see here Paris, St. Petersburg, and London are among those major cities are facing those traffic congestion. The third challenge is the impact. When you speak about traffic congestion, we are speaking about losing time. Time is money. So we can see here the impact on the Asian economies is 2 to 5% GDP a year. And the last challenge is, for sure, is the climate change, the carbon emissions. More traffic congestions means more carbon emissions. Here you see the grew at annual average rate of 1.17% between 1990 and 2022. So these are the major challenges that major cities and government and transportations should address. And to do that, they need to invest in a smart ITS, intelligent transportation solution. But how to start? That's the main question. And based on our experience, we recommend three approaches called ITS 1, 2, 3. The first one is to start somewhere, to start with a basic ICT infrastructure with a device-driven approach. So you put in place traffic signals, cameras, to detect any kind of violation, to control the traffic. So this is a basic approach, and you need a basic ICT infrastructure. So you need to start somewhere. This is the ITS first phase. And then you pass to the ITS second phase, which is platform-driven, data-driven. So here AI, artificial intelligence, come in hand and intervene in order to not only control the traffic, control the incidents, but anticipate and predict the traffic congestion and manage it. So here it's at ITS, at road level. The third stage is at the whole transportation level. So here we are not speaking only about the roads. We are combining and integrating the road sector with the railway, with the aviation, with the seaports, cargo, with the passengers, all integrated together in a multimodal approach. We call it the TOCC, like the Transport Operation Coordination Center. So it's a step-by-step through three approaches. Here, actually, what happens already in China. So you see the curve, the red curve. In the past 23 years, the number of vehicles has passed from 10 million to 200 million vehicles in 23 years in China. And you see the red curve is growing. What they do is that they start investing in intelligent transportation solution. First, they started in the 1980s, 1990s with basic infrastructure, basic ICT infrastructure with traffic signals, radars, basic things, right? And then they passed in the beginning of the 2000s, especially after 2010, investing in an ITS national platform. So you have a platform level, the second approach, the ITS phase 2. And here they start collecting data, analyzing data, and do smart decision-making at road level. And recently, especially in big cities like Beijing, Shanghai, Shenzhen, they started already the TOCC, the third level, where they bring all together data collected from different departments, from different sectors, transportation sectors, and build their TOCC. And this is as part of the Building a Strong Transportation Country plan in China. So the question is where Huawei, where we intervene. What is our role here? Huawei is an end-to-end ICT infrastructure. So in order to better represent this ICT infrastructure that allows the digitalization of the road industry and any other industry, I like to make a quick analogy. Actually, when we speak about digitalization, we are speaking about building something smart. And the being, the smartest being that all of us know is the human being, right? For the moment, at least. So I like to make the analogy with the human being. Digitalization is like the human being. Actually, we are smart because we sense the world around us. We perceive the world around us. We collect data in real time. We see, we touch, we smell. All this data are collected in real time, sent through our nerve system to our head, where there is the brain, who analyze this data and do a quick decision-making, smart decision-making. So here we are doing something similar. In order to digitalize an industry, you need to collect data. You need to perceive your environment. So here you have the cameras, the traffic signals, you have radars, you have any kind of terminals that allow you to collect or get information or whatever. All these perception layer is important, is mandatory to collect data. Then you have the nerves, okay, the connectivity part. So Huawei is providing an end-to-end connectivity solution. Could be IP networks, could be optical networks, could be wireless radio, 4G, 5G, could be microwave, different kind of connectivity technologies. Up to the head, where there is the cloud big data platform, in which there is the brain. We are having artificial intelligence integrated, self-developed artificial intelligence technologies that are integrated into this cloud big data platform. And here you have open interfaces to come and plug smart applications. So we enable the intelligence. So this is how we do it through our end-to-end ICT infrastructure. I will take today just the case of traffic flow analysis and traffic congestion management due to the time limitation. So in order to address this topic, we propose a 3 cognition situation awareness. So as I mentioned earlier, we need to perceive, we need to collect data, we need to understand what's happening on the ground. So the first cognition is the cognition of the road network itself. So you need to understand which roads are congested, at what time. Is it frequent? Is it occasional? Is there any mismatch between the upstream and the downstream, between the entry and the exit? Is there any mismatch between the traffic signal control and the traffic flow? So this is the first type of cognition. The second one is the travel pattern, cognition of travel patterns. So this is more dynamic, related to the vehicle itself. So which kind of vehicles are crossing those roads? Are there trucks, cars, normal cars? Are they visitors, locals? What are the itinerary, where they are going, at what time? So all this kind of information, this data, also has to be analyzed. And the third one is the cognition of the traffic patterns, which is a correlation of the 2 previous ones. And once you have this, you have the visibility, you have this data, you have this analysis, you do this with artificial intelligence, and you will be able to do precise traffic guidance and precise anticipation of potential congestion and anticipate that. So they do that already in China, for example, and on holidays, when they get out of the city, like 46,000 vehicles getting out of the city in the same time. So what they do is they do this understanding, and they anticipate that, and they propose some suggestions for off-peak times for the vehicles. So like 14,000 vehicles use that suggestion to avoid those kind of traffic congestions. All these analysis for sure can be visible on the traffic operation map. You can have the indicators about the safety. You can have the indicator about the traffic monitoring in real time. You have statistical data. You have also real-time monitoring through the map itself. Here it's just showing the roads, but as I mentioned earlier, in some cities, there are already the TOCC that allows you to merge and integrate not only the road traffic, but also the railway traffic. And you can also have data coming from the airports, from the seaports, from the cargo movements. All these can be integrated into one TOCC. And once you have all this perception, this analysis, and this visibility, you can also have the single intersection intelligent signal control. You can also control a specific zone in particular. You can provide green waves to fluidify the flow, the traffic. So a lot of application can be done once you understand the situation on the ground, and you use artificial intelligence in order to do smart decisions. So here, what I'm showing here is more a little bit of on details, is what's really happening, actually. We are providing these radars plus AI cameras, okay, to collect, to detect incidents, to detect the flow. And we have the edge computing, intelligent edge computing equipment to do the computing at the edge, so you reduce the latency and quick decision making. But you can also do it at the platform, as I mentioned. We have the end-to-end ICT infrastructure, as I mentioned, the connectivity, the platform. We have a unified platform that allows to manage different traffic signals, because traffic signals can come from different vendors, so you need to manage that. So we can handle, with our unified and intelligent signal control network, 40 brands of traffic signals. So this is also very important. And for sure, we have the AI platform that I mentioned earlier. So Huawei, in the transportation industry, we've been working for more than 20 years, and in the roadway industry for the past 20 years, and we have ITS projects worldwide, actually, in different countries. We have in Latin America, in Mexico, we have in France with SANEF, with ANAS in Italy, in Ivory Coast as part of the Abidjan Safe City project, in South Africa, with RTA in Dubai, in Saudi, in China, the biggest cities are using Huawei ITS solutions. Okay, thank you for your attention, and I'm glad to answer any question.
Thank you very much.
On time.
That was very fast and very dense information, and I think the audience is still digesting. So there is one first question I'd like to ask, which is about how do you communicate the optimized routes to the traffic participants? So we saw the steering of the system, but how is then the communication done or the data shared?
Between the, sorry,
so when you calculate this optimized traffic flow, how is it then communicated
to the
people traveling, to the cars?
There are actually, you can have either the VMS, the like dynamic video management system, like you have the dynamic screens on the roads where show you exactly the traffic roads where they are blocked or not. You can also communicate with notifications to their smartphones if you have this kind of information. You can have it on your on the website, or for example, you can solicit this kind of information. There is different ways of communication to send it to the vehicles, to the passengers. So this kind of information can be, there are different means actually.
And on one slide, you showed impressive benefits. Is this estimations how you can reduce this, for example, time or emissions, or is it true figures based on the work you did in China? Yeah, actually, it's based on figures based on experience. Actually, the good thing in China, what happened is that they bring a whole ecosystem all together. Not only Huawei. I mean, we are not providing the full everything we can. I mean, for sure there is an ecosystem behind. So they open this possibility through a consultancy process. Actually, so you accompany them from the beginning because it has to be done step by step. And as I managed, there are a lot of cognition, a lot of analysis. So they need to make the data available for you to be able to analyze this data. And you do it through actually several years, not only like it's not in few days that you do that. And you train your models with machine learning, and you build this intelligence, this artificial intelligence, through this kind of data, and propose solutions through this with the ecosystem to solve these kind of challenges. So if we need to do that outside and replicate that outside, we need to have this kind of approach also, bring several players together, spend time, and it needs time. We cannot swap everything in 1 second. Really, it takes time. And there's very similar, like what we heard before from the speakers before, that it needs this ecosystem approach, and then you can contribute as one player within a managed ecosystem. Absolutely, absolutely. So that looks very promising. Thank you very much for sharing your insights. My pleasure. Thank you.